Today, I'm going to talk about several scientific advances of Pilbara Craton and their implications for mineral systems. First of all, I would like to acknowledge many of my collaborators, particularly Hugh Smiths, Klaus Gessler, Heather Howard, and Michael Wingate for this talk. The works are funded by the Exploration Incentive Scheme and involve collaborations with the University of Western Australia and Curtin University, including the John D. Natter Center. So why should we care about Pilbara Craton? Well, Pilbara Craton is Earth's best preserved Archean continental relic. Therefore, it is the best natural laboratory for understanding how continents formed and evolved, which is a fundamental question for mankind. Pilbara is also rich in precious and critical metals. There are several recent world-class mineral discoveries here in Pilbara, including the Pigangura lithium tantalum deposit and Hemi gold deposit. Understanding the evolution of the Pilbara Craton and its ore systems is thus very important for advancing the economy and the transition to green energy. I will give you 4 key take-home messages up front. Number 1. Archean hydrous and oxidized magmas, such as the 2.95 billion years old shulukitoid from metasomtized mantle, are gold prospective. Number 2. The 2.676 GA Gregory Range Suite granitic intrusions and their equivalent volcanics are high-temperature A-type magmatism, which is prospective for iron oxide copper-gold systems. Number 3, the 1.8 GA Bridget Suite granitic intrusions are hydrous and oxidized magmas derived from hydrated lithosphere and are prospective for copper-gold mineralization. And finally, the basement beneath the canyon basin to the east of Pilbara Craton is newly defined as the Proterozoic lithosphere, named the Percival Lakes Province, and the new WAC, which is Western Australian Craton, and NAC, North Australian Craton boundaries are prospective for various mineral systems. Let's have a look at the shulukitoid first. Here is a picture of a typical shulukitoid outcrop showing the 2.95 GA pivot diorite in Manila Basin of West Pilbara. You can see there are abundant Hobland-rich mafic enclaves, which is a characteristic features of this shulukitoid. And recent work sheds new light on the role of lithospheric mantle source regions that became hydrated and enriched in trace element and precious elements by crustal dripping, subduction, or subduction. And remobilization of such hydrated and enriched source can ultimately produce oxidized and hydrous Hobland-rich high strontium yttrium shulukitoid magmas, which are gold prospective. This shulukitoid is abundant in central Pilbara tectonic zone, such as the 2.95 GA Sisters Supersuite that intrude the Manila Basin. These shulukitoids are very prospective and have been implicated in the formation of the giant Hemi gold discovery found by Degree Mining. It contains more than 10 million ounces of gold. Here is an article tells the story of how GSWA's work is fundamental to mineral discovery, featuring Hugh Smiths, the shulukitoid man. It says, in the Pilbara, in the same setting in the Manila Basin, where Smiths found shulukitoids 20 years ago, Degree Mining has made the Hemi discovery. The company has publicly credited Smiths' revelations about shulukitoids as a critical piece of information in the Hemi discovery. And this diagram shows the potential relationship between shulukitoid, trace lithospheric structures, and gold mineralization. The shulukitoid derived from this hydrated and enriched mantle lithosphere can form long-lived and multi-staged magma chambers in the lower to middle crust, where magmas undergo variable degrees of Hobland-dominated fractionation and frequent recharge events. Significant Hobland fractionation results in early and ongoing exsolution of strongly oxidized magmatic fluids containing water, CO2, fluorine, and chlorine, producing a crustal-scale hydrothermal systems. These hydrothermal systems has the capacity to transfer large amount of gold and other metals from the mantle source and the country rocks. In this respect, it probably doesn't matter whether the magma sources of this sanukitoid have intrinsically elevated gold concentration, since this crustal-scale magmatic hydrothermal system has the capacity to sequester metals, large amount of metals across the entire crustal column. And the late orogenic processes can also upgrade the early mineralization. So this diagram really explains well the relationship between sanukitoid and gold mineralization and orogenic processes. The second advance is on the Gregory Range Suite, which formed about 2.76 billion years ago. The Gregory Range Suite comprises granitic intrusions outcropping along a lateral 150 km long belt in the eastern margin of the Pilbara Craton. It is in place during crustal extension of the Pilbara Craton at the early stages of the Fortescue rifting events. As we know, there are numerous base metals such as copper, lead, zinc mineralization associated with this suite. And the intrusion itself is characterized by the porphyritic silogranite with this rapekivi texture, showing potassic feldspar crystals rimmed by plagioclase. Geochemically, the Gregory Range Suite magmatic rocks are enriched in high field strength elements such as niobium and zirconium, and also high in gallium but low in aluminum. They show typical aorogenic or within plate high temperature A-type granite affinity. The Gregory Range Suite is analogous to the A-type granites in the Olympic copper-gold province in the Pilbara Craton of South Australia. There, the high-temperature A-type magmatism, including the 1.6 GA Pilbara Suite and the Pilbara Range volcanics, are considered to be the heat source to drive regional fluid circulation in the middle to upper crust to form the IOCG systems, such as the Olympic Dam deposit. Similarly, regions of A-type Gregory Range Suite magmatism are locations where fluid circulation was active and are likely prospective for IOCG systems. The third advance is on the 1.8 GA Bridget Suite, which is the youngest felsic magmatism in the Pilbara Craton. The suite occurs as small intrusions and dikes in a 150 km long belt to the east of Marble in East Pilbara, and is parallel to the Gregory Range Suite and several northwest trending major crustal boundaries between Gregory Range Suite, Rudolph Province, and Percival Lakes Province. This gravity anomaly image shows that the Bridget Suite occurs in both gravity low and gravity high areas. This is a Moho depth map illustrating that Bridget Suite spatially correlated with some gradient in crustal thickness, and is spatially overlapped with the Bamboo Creek member, which is a volcanic equivalent of the Gregory Range Suite. So both the Bamboo Creek member and the Gregory Range Suite granite are related to the early rifting of the Pilbara Craton. So this spatial correlation and with the morpho gradient and the Bamboo Creek member may indicate Bridget Suite used some pre-existing architecture during emplacement, and that architecture was probably originally produced by the east-west extension or rifting of Pilbara Craton at about 2.76 GA. In the Mosquito Creek Basin, Bridget Suite intrusions stand out as highly magnetic features, as shown in these small stocks and large intrusions. The red circles are samples collected for geochemistry, which will be discussed in a minute. Similarly, in the Mount Edgar Granite Dome east of Marble Bar, Bridget Suite shows distinctly higher magnetic anomaly compared to Archean granites, suggesting they are more oxidized than the Archean intrusions. In the field, Bridget Suite can be easily distinguished as small hills standing out among the flat sea of Archean granites. They have abundant Hobland phenocrysts and also microgranular mafic enclaves, indicating they are hydrous magmas. Here shows a geochronology sample collected from the largest intrusion of the Bridget Suite and placed along the northern margin of the Mosquito Creek Basin. It is a Hobland-rich quartz monzonite. This is an outcrop image and head specimen. This is a shrimp zircon uranium-lead dating results. It is an igneous crystallization age of 1790 plus minus 7 Ma, which is by far the best emplacement age constraint so far for Bridget Suite. It also contains abundant xenocrystic zircons dated from 3.3 to 2.7 Ga. And the abundance of these inherited zircons or xenocrystic zircons suggest they are low temperature magma because of low zircon solubility in these hydrous magmas. This is a whole rock geochemistry comparing Bridget Suite, which is these red circles, with Archean granites, including shulukitoid-like rocks, and the TTG in the Pilbara Craton. It is obvious these Bridget Suite rocks are more alkaline and potassic than all other Archean granites in Pilbara. This is magnesium lumber, chromium lumber, nickel, and potassium sodium ratio versus silica concentration. So it highlights that some of the more primitive Bridget Suite samples have higher Mg lumber, magnesium lumber, and chrome concentration than typical pure crustal melt derived from partial melting of mafic lower crust. Together with their high potassium sodium ratio, it suggests a potassic mantle component is required for the formation of Bridget Suite, and which is most likely metasomatized mantle lithosphere. These are widely accepted fertility indicator diagrams, and Bridget Suite mostly fall in the prospective field or fertile field, indicating they are prospective for copper-gold mineralization, which is dictated by their hydrous and oxidized nature. Now, the fourth advance is about the newly defined Percival Lakes Province to the east of Pilbara Craton. The Percival Lakes Province is the basement under the Canning Basin. This zircon lutetium hafnium isotope map illustrates the Percival Lakes Province is a proterozoic lithosphere similar to the Musgrave, Kupana, and Mandurah Province to the south. Together, they form a 1,700 kilometer long proterozoic lithosphere salvaged between Western Australian Craton and the North Australian Craton. The boundary here between Pilbara and the Percival Lakes Province is probably the sharpest isotope boundary in Australia, and it corresponds to the crocodile-like seismic feature imaged by passive seismic tomography along this seismic line. This boundary is highly prospective, as demonstrated by Tefel and Vilu. This article in Pre-Competitive Review by David Upton tells more about how the newly identified boundaries of WAC and NAC are prospective for various mineral systems. To summarize, we propose that the 2.76 GA east-west rifting of Pilbara Craton produced the Gregory Range Suite A-type magmatism and the favorable architecture, along which the Bridget Suite in place at about 1.8 GA due to a crashing of Percival Lakes Province onto East Pilbara. To finish the talk, I'm also happy to let you know that we have a new project established at the GSWA to understand the lithium fertility of regional granitic rocks in the Pilbara Craton. The cratonization of Archean Pilbara crust appears to have been associated with one of the world's greatest lithium ore-forming events. Stay tuned. Thanks for watching and looking forward to discussion at the subsequent Q&A time. Have a great one.